changeover and control boards, which is the DB system, how they work. Okay, welcome back to this video. Today I'm going to talk about understanding electrical systems, right? So once again, my name is Engineer Isaiah, the CEO of Mosaic Global Engineering Services. And if you have not subscribed to this channel, do well to subscribe to this channel, like, comment, and share to people that want to learn about solar installation, CCTV camera installation, and electrical wiring system. It is very important that you understand this is a 9-switch changeover, right? How changeover works and how you can use it to connect in your watch electrical installation. And this is a 3-phase D6 DB system, right? So this is what we are going to talk about today. But first thing first, you need to understand how these two things work and how you can connect them. So now we have two things here. The first thing here is our changeover, right? The second thing here is our control board. Some persons know it as control board, while other people know it as DB, which is distribution board. So yeah, let's talk about changeover. This is changeover, right? So this is our changeover. This one is called a 9-switch changeover. A 9-switch changeover. We have another one, which is the gear switch. The two are what they are called changeover. Now you should understand what is a changeover. A changeover is what we use as a source of isolation when you want to isolate your distribution board from the house or from power supply. The changeover is what we use to isolate. It serves as a switch and also an isolator. You can use to engage, then you can use to disengage, right? Put it on the middle, which is neutral. Then this changeover, let me explain, is a nice changeover before we go over to what the gas switch changeover. Understanding this changeover will make your work very easy. And for those that are learning this system, it is good for you to understand how to connect changeover like this, even in a basic wiring system. So as a matter of fact, changeover you are seeing, this changeover you are seeing, this our changeover, we have input, and we have what? Output. Right? So this is one input, this another input, then this is what? Our output. So that is how changeover work, right? So you can decide to connect your NEPA in this place. You can decide to connect your generator at the bottom. But the output of this changeover, it is where we go to what? Your distribution board, right? So as a matter of fact, this changeover is what? 2 input, right, and 1 output. So let's see how this changeover works and how we can use to connect to our system. So this is a changeover, and mind you, the changeover, this is an electrical system that has to do with AC system, right? And I hope we know our AC sine. Its sine wave is like this. These are AC sine system, and in AC we make use of live and what? Neutral. So make use of live. This one is live, and we make use of what? Our neutral line. Neutral, right? So you can see that they are interconnected together like this. In the fact that if you switch over to this up, there you have already engaged. You take a look at the changeover. You see my hand. If I switch over to this up, I've already engaged the middle and what? The up, which is the NEPA side. If we are using up as NEPA, then I've engaged it. So whatever power supply I connect here will also appear as output. Then if I turn it down, I've already engaged. You can see the conductor. I've already engaged between the down, and it will give me output in this place. So this is how changeover work. So for those people that connect changeover or install changeover in the home, they use 2 sources. Either they use up as NEPA, they use that as generator. And the beauty part is that this changeover has indicator. When any power supply, even if you run gen at your bottom, comes here, this light, this LED will come up. These are indicators telling you that there is a source, there's a power supply inside this system, right? So now we are going to look how they are being connected. Now let me draw what our changeover. This is our changeover. Then we have what? These are what? These are NEPA, right? These are NEPA. So these are NEPA, right? If you come to fuse, I hope we know what is called contact fuse. These are fuse, these are fuse, these are fuse, right? But we are not going to talk about fuse system. We are only going to focus on our changeover. Then in this changeover, this is the changeover, right? This changeover, we have the input at the up, we have the input at the bottom. Then, okay, we have this as what? We have this as what? As our output. So now this is how the changeover works, right? So we have this line. The changeover can be labeled A and B, but understand it, right? Because every engineer or installer or electrician with their own design. So I can decide to use this, my left side, right, as my what? My life. Then this one will not be, this indicator will not be for life. Then indicator will not be for life. Then this one will not be what? For my neutral. Then in this place, I will also have another life here, right? So let's say at my right hand side, I will use it for what? My neutral. It will not be N. Here will not be what? Right? Then this place will not be. So now I also have what? I also have a generator, right? We also have generator. So let's use this. These are what? Our NEPA, right? So let's use this as our what? Our generator, our gen. Now we are considering two power sources, our NEPA, our gen. Okay, remember we have them doing what? We have them interconnected together that we use this between the middle conductor and the up or the down to engage in between the two, depending on the power source you want to use at a particular moment. So this is how they are interconnected together internally, like this, right? So at the end, we now have our output. Then again, we have what? Our DB. So it might be single phase, it might be three phase. That is the major DB we have basically on house wiring. And I will talk about the DB once I'm done with this changeover. And once again, when we're talking about this connection of changeover, now you can see that this is a single system. This is a changeover that is a single phase, which is the live and neutral. We have changeover even in night switch that are what? Three-phase system. But now, for the sake of those that are just coming up and learning this wiring, let's use single-phase system as our illustration. So in a single-phase system, the wire that will be coming from your fuse, which is from your NEPA or from your meter, right? It will be two wires. It will be red and it will be black. So these are the two wires you will see coming from your NEPA, basically. So now we have to connect what? We have to connect our life to this point. Remember I said this input 1, this input 2. So another thing, we take our black wire, then we have to connect like this, right? We now come to this place. So we have successfully connect our NEPA to the upside of the changeover. Now we come down to what? To our generator. Remember, our generator have three phase and single phase, but we are talking about an average home that are using basic home appliances are running single phase generators. It can be on fuel, it can be on diesel. So now we pick our what? Our life wire, which is this wire, right? We pick our life wire and we'll do what? To connect it to this point, right? Now we now pick our what? Our black. Then we do what? We pick our black and we run it to this point. At this point, we have successfully connect our what? Our red and our black. Then we need outputs from this system. How can we connect the output? The output is already what? On this system. Now, before anything, you need, right? This is what? We use this as what? Our DB, right? Then this is our house. From DB is a sub-circuit to what? To the other appliances, maybe your light, your fans, your AC, water heater, and all that. So let's say this is our what? This is our building, right? So let's say this is our building, right? So remember, the DB will still be inside the building, but I just want to use as a block diagram to connect that when the output comes to what your DB, from your DB, it will not circulate what to the full house. Maybe your light, this can be light, it can be socket, this can be AC, this can be fridge, this can be water heater, and all of that. So as a matter of fact, having done that, we now do what? These are output now. In case if NEPA comes, right, you engage what? You switch the changeover up, it will give you what? Output on NEPA. So now let's connect it to DB. You connect, you take your wire, then you connect it to your DB. You take your what? Your black, connect it to your DB. So by this point, you successfully use a changeover to bring in two different power sources to power what? Your house through the help of the DB, right? So this is a single phase system. I have to connect it. Now we have a three-phase system. Then, okay, so we have three-phase. We have three-phase changeover switch. But mind you, before you talk about three-phase system, you have to understand something. In a three-phase, we have three live, three wire, which is our what? Our what? We have our what? ROYB. We have our what? Our red phase. This is a red. This okay, let's use we have our what? Our yellow. Right? And we have our blue, ROYB. This is arrow, this is Y, this is B. Okay, since we have a blue marker here, let's just use blue. They have blue phase. So this phase now comprises of the three-phase system. Then we have neutral. These four things make up the four what? Wires that we have in three-phase system. That is why our second distribution line, which is the pole, right, have four lines. Which is when the power comes to transformer, they step it down and it comes from transformer. It will give you four what? Wires on the pole. Basically, we have four. The one at the top is the red phase. The one under it, the next to it is yellow phase. Then the third one is what? The blue phase. Then the last one at the bottom is the what? Is the neutral. That is how it is generally. So now, let me bring our mind back to three-phase system. So you can see a gear switch, example of three-phase gear switch changeover on the screen, right? See it on the screen and how it is. But let me just give you the structure, right, of a three-phase system. So it have a handle where you can engage it and what? Pull it on middle. So it have engagement 1, 2, 3. Do what? And 4. Then 1, then 2, then we have 3, then we have 4. So as a matter of fact, there is a connector between these two. There's a connector that connects the gas switch changeover in this place. There's a connector here, there's a connector here, there's a connector here, there's a connector. So basically they are being labeled, right? S1, S2, S3, then we have N1. Sorry, which is the neutral. Then we also have S1, S2, S3. Then in the neutral aspect, we can label it as L1, L2, N1, N2. Right? So these are neutral line. So in this one is labeled on L1, L2, which is our load. L3. Then we have it L1, L2, L3. Are we together? So this conductor you are seeing now, this line, now this string now, right? Then it is what that connects both sides together. So assuming you bring in NEPA, right? Let me say this is what? This is our NEPA. Three-phase system, right? So you bring in NEPA, you now see that, okay, remember is three-phase now. Red phase, yellow phase, and blue phase. You run it, number one, you run it one phase here, right? Then another one, you run another one, which is what? The yellow phase. Take another one, you pass it to this place. Then The blue phase, you pick what? You run it to this place. So you have successfully installed these three lines. Then your neutral also will also follow. Then your neutral also, you pick your neutral, you run your neutral again from this phase. Okay, let's pick our neutral, right? We run our neutral from here down to what? To this one. So these are three phases. Do the same thing for generator. Then your output, you will now connect your output in this place. The output will be on this other side. This L, on this L1, L2, L3, which is your load. Connect it like this. This is L2, like this. This is L3, then like this. Then this is what? This is neutral. Right? This is neutral. Like this. So here you have L. Then here you have arrow, Y, B. So this is the complete system of three-phase system. Though this system is not common, they are usually found in a standard building or a factory. This is where you will see most of the factory, they don't even, their machines are operated on three-phase, even without neutral. But in a normal building or in a normal circumstances, you're supposed to have three-phase system coming to your house directly without bypassing anything. But now, let's not talk about how to use single phase, right? Let's talk about how to use single phase. Maybe a single changeover on what? On single phase DB, right? Or using single phase, which is what is basically common. It is our system. This is a three-phase DB, but we end up using single phase, looping all the old wires to power this DB with one phase, which is not ideal and professional for electrical installation. So now we are going to look into how we can use the single phase to power what? Our DB. Okay, so now let's talk about this control bus. We have single phase DB or control bus, as some people knows it. We have what? Three-phase DB system, distribution board. So single phase DB is where you have what? Your example of single phase. See example of single phase DB on the screen. Yes, you can see it on the screen. Example of three-phase DB. You can see the you only have, and remember in single phase we have them in different ways. We have a three-way, we have what? Four-way, we have five, we have six-way, and thereabout. The same thing happens to this three-phase, but in these ways, instead of calling it three-way, we could refer to them as what? D3, D4, D5, D6. So in a normal conventional electrical system, or someone that is grounded in electrical, you know that once you make sure single phase D4, it's telling you that D4 means 4 breaker inside the distribution box on single phase. If you tell you that okay, I need single phase DB D6, it's telling you that the DB to carry 6 breakers, or some people know it as star blocks. So now let's explain this system, right? On let's talk about let's talk about three-phase DB. So this three-phase DB, and we have 3 examples of a three-phase DB here. So I want to explain thoroughly how this three-phase DB works. So follow me, and you will see how the system works. Okay, so now this is a three-phase DB. Please pay attention. I want to explain something very, very important that most electricians or technicians did not know. So in this place, this is a D6 DB distribution board. Like I've said, we represent this number of breakers or star blocks in this system as what? D4. If it's D4, we have 12 breakers here. If it is D6, we also have what? How many breakers here? 18 breakers. Then remember, make mention of 3 phases. We have what? The red phase, we have the yellow phase, and we have the blue phase. Now take a look at something very important. The same color that is here is the same color that they told us that is here, and also at this other end. So we now see that this red phase, you have how many breakers? Have 6 breakers. Remember, we have said we have 6. This breaker is 18 breaker. Let's count if it is complete. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is a complete D6 three-phase distribution board. So as a matter of fact, let's see something. This red is this color. How many red? Okay, let's count together. How many red we have? We have 1 red, 2 red, 3 red, 4 red, 5 red, 6 red. That is 6 on this red line. Okay, let's go over to yellow face. How many star blocks or breaker we have for yellow face? Let's go account now. We have 1, 2, 3, 4, 5, 6. Okay, let's go to the last face, which is the blue face. Let's count. We have 1, 2, 3, 4, 5, 6. So everything sums up together to give us 18 star blocks or 18 breakers. So these are the system works. Now I want to open this DB. Then let's see what is inside and how it is being interconnected together before we proceed. So this is me opening the system. This is me opening the. And before we open it, your DB will be closed like this. Don't worry. So this is me opening the system, the DB. Let's see what is inside this distribution bus. Let's see what is inside this distribution board and let's talk about it. Okay, so I've removed the 4 screws that hold it. So let me do what? Let me remove it and see what is inside the system. So now, this is the system. This is what? The distribution box. Hope we can see everything. Okay, now let me explain the DB as a unit in the electrical installation systems, right? So this is the main breaker, right? So let's remove this and see it very well. So this is what our main breaker. As it is now, it is off. If I switch it up, it is what? It is on, right? So this is like the powerhouse. This is where your power source will come into, and it will distribute from here to all the breakers. So when your NEPA comes here, then it will not affect or it will not supply to all these star blocks or all these breakers. And we have 2 different links here. We have what? Our neutral link, we have our earth link. So for the sake of color coding, we use black cable to run our neutral link. We use what? The red to connect to what? Our star blocks, which is we connect the red cable to this point, to this point, to this point, to this point, this point. While our what? Our black cable will be connected to this link. Our power supply cable will be connected from the NEPA or our output of changeover. This output of changeover, it become output of changeover, it become what? It become to this black, this terminal. Then we have our what? Our earth link, right? Coming to this earth link. So these are the 3 wires majorly you found in this system, right? We have our black, we have our red, and we have our what? Our green. So it's very important as an electrician or a technician, or you want to do simple installation yourself, then you have to know how this system works. And this breaker you are seeing, we can pull it off. Let me remove this one. So I can remove it. I can remove it. Okay, let's remove all the old breakers and see how this system works. I can remove it. I can remove it. Then I can remove everything. Now I want to remove everything, and I want us to see how this system is designed internally, how it is being done. Now I've removed everything. You can see the internal. You can see how it is being connected, and you can see. So sometimes what you have to do is that if you are doing electrical work, you will do what? If you are doing electrical or solar installation work and need separation of load, you will do what? You have to test. So now we can see this line is connected to some part. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. This one have what? 3. This one have 3. This one also have another 3. This last one have the other 3. They are interconnected inside, right? So now, in case you are installing solar system, and as a matter of fact, you want to check which one, maybe the front label is not there. As electrician also like solar, you have come to do load separation. Then once we fuse this thing back, the star blocks, once we arrange the back, then I will now explain to us how to use multimeter to find out the lines that are connected and how to do proper load separation, right? Okay, see you in the next video. Remember to subscribe to this channel so that you can learn more as we upload more videos. Remember to share to other people to learn freely. Then remember to comment. And one important thing is that tell me what you want to learn in regard to CCTV camera, solar installation, and electrical. Tell me the next video I should do for you. Anything you want to learn, drop it on the comment section, and I will record that video and drop it here so that you and other people that want to learn it can learn it for free of charge. See you in the next video.